Okay, so we're just going to continue on from notes from yesterday. They're not very long, so I'm going to put a little line here just to kind of separate the 2 days. Okay, so a function can be one of two things. It can be a continuous function. Go ahead and leave a space so we have room to write the definition, or it can be a discrete function. Okay, so a continuous function means it can take on any number. So that means it could be rational numbers, it could be integers, or it could be whole numbers. Okay, rational, remember those are decimals, remember those are negatives, and those are just our regular numbers that we like to deal with. Discrete, however, only certain numbers can be used. So most of the time in this situation, we're talking about whole numbers. Occasionally we'll have, we're going to put, I don't even know, sometimes, let's do that because I don't know how to spell occasionally. Sometimes we have rationals in this case, but most of the time it's whole numbers. So I'm going to show you what I mean by this. This would be example number 4. Let's first talk about the number of glasses in a cupboard. Number of glasses in a cupboard. Can I have any type of number of glasses in a cupboard? Could I have a negative number of glasses in a cupboard? No. Can I have a decimal amount of glasses in a cupboard? No. I can only have whole number glasses, right? 1, 2, 3, 4, 5. I can't have 1.5 glasses in a cupboard. So this is discrete because only whole numbers work for that one. Let's do number of ounces in a glass. Now, ounces could take on a decimal, right? I could have 1.35 ounces in a glass. So it's going to be continuous because it could be a decimal. Let's do amount of money made in the store. See, the amount of money made in the store, let's just say for a day, that's going to be continuous as well because they didn't just, they had taxes, so that adds decimals to things and things like that. Okay, last one of these, we'll say number of people in the store. Number of people in the store. That would have to be discrete because we can only have whole number of peoples. We can't have half a person, only whole people. Okay, so that's kind of the simple thing here. On a graph, so if you're looking at a graph and trying to figure out whether it's continuous or discrete, look at the x-axis title. And that'll give you one of these, and then from there you can figure that out. So let's flip back to yesterday's examples. So example 1, my x-axis here is book covers. Discrete or continuous? Well, I can only have whole number book covers as we've shown here, so that would have to be discrete. This one, X is apples. I can buy half an apple, but do I want to? No, I want to buy a whole number of apples, so that would be discrete. And then Now, a lot of people look at this, they see the money and they say, oh, it's going to be continuous. But remember, we look at the x-axis. That's what we're measuring. So number of days late, that is also going to be discrete. All right, so your homework today is a quizzes assignment. It's literally just a lot like this. You can take it as many times as you want until you like the grade, but that is all that you got today.